I know. Probability theory isn't that
All right, welcome to another exciting microcontrollers class. We're going to get right back into it.
Hello. Oh my God, we're going to that.
I'm starting because we came in 5 minutes late and I don't want to lose too much of your time. I just don't. It's not fair. So what we had here is a homework 2, which has been uploaded with some sample code. And that will allow you to get jump started pretty quick. But let me give you the bird's eye layout on this paper. What we're going to be doing is we're going to take the Arduino and we're going to convert it into a distance measurement device whose output consists of 3 LEDs for when you are too close, a little close, pretty far away, and really far away. And here's what I've got. When you're really far away, you get 3 LEDs. And as you get closer, 1 goes out, 2 goes out, and then all 3 go out. So that shows you sort of like your range away from the LEDs using the sonar sensor. And that's what we want to construct today. And so what I think you'll find is you have an HC SR04 ultrasonic board next to you, as well as 4 DuPont cables. So the HC SR04 sensor is capable of emitting an ultrasonic chirp. In order to maximize the probability of an echo return, the chirp consists of usually 4 separate frequencies, and as they bounce back, you get an echo in microseconds. There is a little bit of a inversion factor when converting from microseconds into distance. You have to know the speed of sound, the speed of your chirp. And so what you want to do is, and you'll see this code that's in homework 2, so you can paste this in and it'll start to work directly. You'll find that your sensor has 4 pins coming out of it. And those pins are power and ground, +5, and ground. And I've been using sort of like red and black, but you can use any colors you want as long as you're consistent. And then there's 2 operational pins in the middle. And those pins are labeled on your board as trigger and echo. And I'm just going to write T and E, trigger and echo. And then what I did was I said I'm going to wire the trigger pin to pin 7 and the echo pin to pin 6 on the Arduino. If you change that wiring, and you're permitted to do so, you will have to change your code. I'm leaving this because it says D3 and D2, and I'm not doing that. So that's the code as it is. I think you can probably get that from homework 2 off of the microcontrollers lab. And then what I did was I established the echo pin as my input and the trigger pin as an output. So the trigger pin is going to emit the chirp when you toggle it. You toggle it to 0, and then toggle it to 1, and then back to 0, so the chirp goes out. And then the echo pin is going to be red, and that's going to give you the microseconds that it takes for a chirp to come back. The serial.print line is just printing out the HC SR04 test with the Arduino Uno R3. And then over here, I got a little for loop that goes from pin 9 to pin 14, actually pin 13, so this is less than 14. and it's going to set every one of those pins as an output, and it's going to set every one of those pins as 0. So what I've done is I took 3 LEDs, and the short pin, that's going to be negative. The long pin, that's positive. And so what I did was I plugged in the LEDs to ground, and then pin 13, and then I make 11 ground, and then 10 will be the thing we toggle, 9 will be ground, and then 8 will be the thing we toggle. And so all you need to do is toggle pins 13, 10, and 8 for your output. And you can see the pattern that I'm using. Everything's off, 1's on, 2's on, or 3 is on. That's my pattern. So in order to achieve that pattern, what I did was I decided to create a set LED based on the byte. Now I could have done this where I have LED A, B, and C, but if I want to add like 5 LEDs, it gets a little tedious after a while, and this makes the code a lot cleaner, a lot more elegant. So by encoding everything in binary, using a binary representation of these decimal numbers, we can see 0, 0, 0, 0, 0, 1, 0, 1, 1, or 1, 1, 1 as the base to the equivalence of the decimal radix equal 10, radix equal 2 numbers. So by using these binary numbers, I can set the pattern, what I call set LED. And then I start off at pin 9, just like before. I've got to go on odd number pins now, because of how I plug things in. It's got to go 9, 11, sorry, and 13. 9, 11, 13. Can you do this backwards? 13, 12, 11, 10, no, there. Here it comes. So it goes 9, 11, 13. And so that's what I would expect for the pin numbers if I increment by 2. 9 plus 2 should get me to 11. And then go through it again, gets me to 13. Each time I take the byte, I shift it to the right by 1. When I shift it to the right by 1, I can get the least significant bit out by using this bitwise AND with the 1, using that to do the digital write. And then I've got an opportunity to essentially write a very elegant byte-driven program that's going to set the LEDs, and I can have as many LEDs as I want. If later I want to have 10 LEDs, I can change this index in here, and it will still continue to work. I may have to go from byte to something like short, but it doesn't matter. It's a relatively, certainly can do it to 8 LEDs, and it would be no problem. 8 LEDs is probably all the Arduino is going to be doing without some kind of multiplexer. So that's a that leads us to the loop, right? So here comes the loop, and it might as well make sense for me to go through it, right? Because your trigger is different from your echo. Your trigger is your controller for the chirp. So you set it low, wait 2 microseconds, then you set it high, wait 10 microseconds, and set it low again. That outputs the chirp, the 10 microsecond chirp. And then you got to read the pulse back in from the echo pin, and that'll give you a duration in microseconds. Then you want to take the duration in microseconds and figure out what the travel time would be. Divide it by 2 because it's a round trip. And then you'll have your total distance in centimeters. So that's a centimeter conversion factor for the speed of sound at standard temperature and pressure. So then we print out the distance, but I want a display. I don't just want serial port output. So what I'll do is I'll write an if-else statement. You notice the if-else is being written as, else if is being written on one line. That's a code style that I happen to care. I like this code style. It makes it compact. If it's less than 10 centimeters, this executes and nothing after will execute. If it's less than 20 centimeters, this executes, nothing after executes. So some 30, this executes. So some 40, this executes. And because I'm using binary with a capital B, don't type like 2 in here. Somebody said, I'll put 2 in there. You can't. It's binary, 0 or 1. If you put a 2 in here, the compiler will go, oh, yeah. And it says some more eloquent thing in there. But, I mean, it just doesn't like it. So this is a literal that's embedded in binary. You can see the pattern of the LED as you type it in. You can certainly extend this to extra LEDs if you wanted to, but you don't need to. Then you can see how the centimeters thing is working. There's 2.5 centimeters to the inch in case you're metric challenged like me. And so 25.4 millimeters to the inch if you want to do it in millimeters. And so if it's 10 centimeters, divide by 2.54, and you get a number. It's probably 4 something or other. And then you can see this is like 4 inches. Maybe that's 8. Perhaps this is 12. So that's how that's working. And when you go and you hold up your little range sensor thingy, you can kind of, I guess I can hold it like this. Is it working there? There we go. Shows how far away you are. I don't know if you can see that in the back of the room. There it is. So that's the range sensor. And now, if you wanted to, you could also show the serial monitor, which is actually giving you a fine-grained look at the distance. And now I've got you in my scanner, and you can kind of see how these things are changing as a function of distance in that. How do you access that again? So you got to go to homework 2, and you got to paste the code in from homework 2 if you want to get started. You know, that's not going to be the completed code. You still have to complete a little bit yourself. So I left you with something to do, but it'll get you started to the point where you'll have a printout on your serial monitor. But first, you've got to wire up your Arduino shield. Trigger and echo is, your Arduino sensor. So trigger and echo are going to 6 and 7, 7 and 6, respectively. So this goes to pin 7. And that goes to pin 6. And when you go to red, you know, I couldn't get mine to work because I plugged it into 3 volts instead of 5 volts. It really doesn't run on 3 volts. Runs on 5 volts. So there's like 2 pins right next to one another on your Arduinos. One's 3 volts, the other 5 volts. Make sure you got the right pins. And let's see if I can find. Oh, we got a participant. Oh, that's you. Okay.
Yeah, I just answered the thing.
Okay. Can you see everything all right on your
Yeah, I can see
device?
that.
That's good. So we've got a participant and it's in the class. That's fine. That's fine. And what the other thing you can do, I mean, you might like to do is you could look at the LED demo that I created this morning on Vimeo. And in this case, what happens? Let me see if I can make this large. So now you can see using Tinkercad, I got the same thing. It's so handy to do this, you know, in the comfort of your home without having to deal with uploading hardware and all this other stuff. And we may end up doing this if we end up, I don't know, going on forced break because of distance learning and COVID. But you can kind of see how the trigger and the echo are being used for the green and the blue on pins 7 and 6. You can see my LEDs are plugged in directly. I don't need a breadboard for this. I just need 4 DuPont wires and 3 LEDs, and bang, I'm done. Now, if you see some of the samples online, you'll see they're using breadboards, and that's nice, but you don't have to. Now, for the simulator, you click on this crystal. And when you do that, when you click on the crystal, you get a display that you can interact with, which is really cool. And when you drag the little thingy in there, let's see if you do it. you'll see it updates the distance away, which is awfully nice. And if you can open up the code and show the monitor, you will be able to see the distance as a function of time. These LEDs are now changing value. It's hard to see on the screen, but it's easier to see when you're looking at the computer. And what I'll do now, I think, is I'll show the code, and I'll also show how do you say, serial monitor output. So we'll stop the simulation. Let's take a look at the code. And now you can see a rather less elegant, less refined approach to doing the similar thing that we just saw from before. The read ultrasonic sensor is the same. The serial begin is 9600 baud, so that means your monitor has to be at 9600 baud. But the actual LED settings are not as elegant in this particular version of the code. Although we cleaned it up a little bit for the homework too. And so here you can see what's going on. Pin mode for trigger is an on output. We write low, wait 2 microseconds, then write high, wait 10 microseconds, do a digital write on low. That finishes the trigger, the chirp, and we go read the echo pin and return a value. And this is that same value before divided by 2, so that you could have an opportunity to avoid a division. And that gives you a microsecond read on output converted. This is the microsecond read on output, and this gives you the conversion to centimeters. And here I am writing out without an if-else, and you can see how the elegance has been lost in this particular version of the code. This is an early version where we had an if statement that had bracketed the centimeters and say, well, if it's in this range, write this, and if it's in that range, write that. And there was a big dispatch involved. And I've replaced all of that now with a single binary invocation with a pattern that allows us to use masking in order to be able to make the code rather more elegant. And also, if you use if-else, you never have to have a giant dispatch like this. It doesn't make sense to do that. And the duplicate code is another bad smell. You don't want that in your code, in your program either. So all these, digital writes that are written out, that's not a good way to write code. It doesn't make it look nice, and it isn't elegant. And it's hard to maintain. In fact, if you think about it, it'd be particularly difficult to add just one LED, because you have to visit the code in 4 different places, which is not nice. So it's better if you can centralize these sorts of things. So here's what I do. I write LED, but in this case I said, let's just use 3 LEDs, and I put them in as A, B, and C. Instead of putting them in L1, but L's look like 1s, so I changed it back to A, B, and C. But then later I said, why don't we just use a byte and use the masks? And that actually relates back to class, why we need to use masks for binary numbers in order to be able to communicate efficiently with our hardware. So here all I want to do is write out the state A, B, and C to my 3 LEDs. But later, after I got that working, I said, we can do better than this. And that's when I came up with the idea that we would just use the bit mask. So look how much cleaner the code gets if you use write LEDs over in here. Just put in 0, 0, 0, and everything turns to 0. And now you can replace that, those 3 lines, right? We're getting rid of like 9 lines of code, 12 lines of code. Because these 3 digital writes appear like 4 times. And that's, that's a bad smell like that. So making it smell just a little bit better. And that should be a 1 now. But you can kind of see how it got cleaned up. A whole lot nicer right in through here. Now, if you replace this with else ifs, you don't need to have all this complication in the dispatch, where the if statement is bracketed in centimeters. But what I liked about this was it works so nicely by dragging, the little object around. It simulated the ultrasonic sensor nicely, which I thought That was great. I never see that in a simulator. So to see that in the simulator just makes it cool. So the way we'll work it is this. If you want to use the simulator at home to do this, you can. You're not going to have an ultrasonic sensor at home, but if you can get things working in the lab right here, right now, just take a picture, put your code up into a Word document, and upload it to Homework 2, and bang, you're done. And I think we got 35 minutes left. You should be able to finish it. So let me get out of this. Get out of this. Here it is with a 3-pin sensor. I've uploaded the video for that in Homework 2. Let's see if we can get the code that I just wrote back up in here so you can see it. So now, remember how that dispatch was written before with 3 variables being used as arguments for SetLED. We put in 3 states. Now I just put in a single byte with the actual binary coding. And that actually makes life a lot nicer. In fact, if you wanted to add a single LED, I don't actually know if I have one, but you could just by modifying the code a little bit. I'll fresh out of LEDs. And I see another simplification in here. This code where it says 0.034 divided by 2, I think these computers have calculators. Yeah, I could probably say 0.034 divided by 2 is, yeah, same as before, 0.017. So make that 0.017. Forget about the divide by 2. Remove this divide by 2 thing. And that should work the same as before. It says it's done uploading. Let's see if it works. And it does. So there you have it. Your sonar sensor is now working with the blinky lights. So last time we learned how to do blinky lights. This time we learned how to do the sonar sensor, and we added the blinky lights from last time to give ourselves a nice output. And Chris, I think you have something you can demo as well. Isn't that right? You can probably bring the camera over here. I wonder if I can make this full screen. I don't know. Let's just sort of.
If you stop screen sharing, you can.
Where do I stop the screen sharing? Here or there?
Over there. And then you would make that whole screen.
All right. Well, but people are copying what's on here.
Yeah.
So let's not do that. I'll just do this. So what Chris has done is he's 3D printed the sonar bracket, which is mounted on top of a servo, which we haven't done yet. Servos we can do for our next class. So here is the servo turning, and as it turns, you can see a scan. I don't know if I can put the screen up in there. We've got an outlet that's not too small. That's all. If you can see the
Oh, there you go.
yeah, you can see it turning, and that's kind of cool. So it has combined the servo with this ultrasonic sensor, so he can build a kind of a scanning sonar system, scanning rangefinder, which is, yeah, that's cool. I like that. Yeah. So it's just a matter of finding, the bracket was nothing more than a 3D printed object that I guess you got on Tinkercad and modified a little bit.
Yeah, I'll think it first, but yeah, I just had to modify the sizing a little bit. It was perfect.
because a lot of people, I think, have these sonars. They're very inexpensive on eBay. That's why we have them. And they're really good for robotics projects, or if you want to make a biomedical device. And we have a grant for that, in case you want to get into it. And so if you have people who are blind who are looking to make sonar panes so they can see, it gives you kind of feedback that enables you to see what's ahead of you without having to touch it. So that's a legitimate thing to do with it, I think, for a biomedical device. Yes, sir.
Getting an error that says CM is not declared in this state.
Yeah, it's possible that you need to do something where CM is declared as an integer, so that distance can be used. So if you wanted to, you could probably see what I did to get CM declared. I went to the top and I just said int CM.
Right.
Because if I did this and I just wrote distance everywhere, that wouldn't work real well. So I guess I could have written distance everywhere and gotten rid of the extra variable. But I said, CM is so much easier to write than distance. And I just put CM everywhere and set CM equal to distance so that I could use that in my argument for my for loop, my if statement. Anybody else have any questions or errors? More LEDs. We always seem to run out of. Yes, I did. I brought in a whole bag of blue LEDs, hoping everyone would have enough LEDs. Needs more? Who needs more LEDs? You need stuff like this, you gotta tell me. Everybody got enough cables and a sensor? LEDs? Yes, sir.
So
Yeah, let me see what I got on the top here. I may have changed it just a little bit. I think I went in yeah. So right, I got echo pin is 6, trigger pin is 7. So when you're wiring up the trigger and echo, you want trigger to go to 7 and echo to go to 6.
yeah, but then we have to designate that later. Right?
No, No. Trigger and echo are constants right here. Trigger and echo pin don't change unless you want to add more sonars. You can have 3, 4 sonars on this. And then, if you were building a biomedical device, we built a printed circuit board with 3 sonars. And so we needed 3 triggers and 3 echoes. And actually, if you think about it, having multiple sonars improves your precision, right? Because you get crossing echo pads, and you have an echo at different intervals. Also, you can improve your angular acuity on a sonar using a horn. Yes?
I'm getting this error message that I really don't know.
I'm gonna get my glasses.
No, you don't need to. You're going to use them later to reach that. Just declare them up there so that you can use them in like different functions. Right? Otherwise, yeah, it's long. Make that a long. Yeah, well, and that'll have a.
So if you guys are able to get things working here and you can take a picture and upload your code, we'll call it done. That'll be good. If you can't, you gotta have it work at home, you can use Tinkerpad and try and get it working with that, and just take a picture of Tinkerpad and upload your code. Put that into a Word document and just upload it to a signed form. Scroll down? Sure.
You can also you can probably zoom out a little bit. It's pretty big.
Well, I guess some people said they couldn't see it in the back, but I'll make it smaller.
It's probably better to walk up and look at it and not be able to see half of it.
All right, well, how do you make it small?
Control minus.
Control minus? All right, let's try that. Can you guys see it okay?
Yeah.
Is that what you're looking for?
No, so he doesn't actually have.
So we're starting at pin 9. We skip every other pin because we want to go 11 and then 13. And each time we shift over to the right by 1 bit. Our bitwise AND will return 0 or 1 because we're looking for the least significant bit. And that's going to be able to associate the 0 or 1 with one of the LEDs that we're interested in. So pins are skipping by 2. And the byte is being shifted by 1 each time.
So all these LEDs do, but when you get within a certain distance, one turns on, you get closer, two turns on, very closer than that, you get all three on.
Okay, so you make this set, so you have this set LED function, so that's good. But you change read to your byte, which means now instead of just setting those all to 0, you're going to want to set them to the first, instead of doing like these, so you are doing it right now, yeah, so that works. You're going to have to do that function.
I could probably change it from byte to int or something.
Sure. So you actually not do it.
Yeah, if I change it to short, is that changing anything?
It's set LED.
Do it like that, and the reason that's good, you're going to have one digital.
So with the short, you got 16 bits, and that'll enable you to have as many as 16 LEDs, although you may have to shove over the trigger, because I got trigger and echo on 6 and 7. So we can keep going. Well, you see, you're wasting pins when you're using pins 10 and 11 as ground, but it just simplifies the wiring. That's why I did that.
So that's just the number that you're starting at. So your high gains for this are 9, 11, and 13, right? So you just starting at 9 and then do a four that iterates to each time, so that he gets to each of the high gains and then turn. So just it looks a little more wonky, but then it makes it a lot more complex or less.
So just for yaks, I moved my trigger and echo pins to 3 and 2. And I think it'll still work. Let's see if that's true.
Yeah, so that's a bitwise.
Yep, still works. So that gives me more room for an extra LED if I want to put one in there. I think I have an extra LED in there somewhere. You're not getting an error, or you are?
I'm not, but it's just not working.
Oh, it's not working. Oh, well, that's different. Want me to look?
Absolutely.
Okay. If you look over in here, where I set pin 9, it's outside of the for loop, so you keep setting up pin 9. All right, check it out. You put set pin 9 inside of the for loop, so every time at the head of the for loop, it's going to set pin 9. What you're looking to do is start on pin 9, set up pin 9 where you want it, and then increment the pin number out inside the for loop. This pin 9 only gets set once. And then the pin keeps incrementing by 2 because you want to go 9, 11, 13. So if what you want to do is have an extra LED starting on pin 7, you'd start your pin here at 7, and then you'd set your outputs at 7, and then you set your bits to an extra 0 here, 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 and here. And then when you want it to go a little bit further, copy, paste, make that 50, and put all ones in there. In theory, that should do it. So adding one LED doesn't require a major amount of effort. Let's see if that works with 4 LEDs. Yep. So there's 4 LEDs all lighting up. That seems to work. That's cool. Four LEDs, no way.
So when you're using this function that he has, you no longer need these 3 lines. Because this is digital writing each of those 3 as a group. Does that make sense? Yeah.
Do you have any other LEDs?
Yeah, they're in the stock room under blue LEDs. You know where they are? Oh, wait, here they are. I'm sorry, they're on my desk.
So open your serial monitor so we can actually see the numbers. You can press Control-Shift-M, or you can go Tool Serial Monitor. So it is doing something.
Sure.
Let's see that. Yeah. So that's your work.
More?
Yeah.
That good?
One of the reasons it's being a little
Yeah,
weird
up.
is because as you get to the border,
You mean
these are not
the other up?
perfectly accurate, you know, maybe with half a centimeter they can be off. So you
Is that
could be
good?
holding it
More?
at the same spot and have that light be blinking because it could be reading like right above and below it. See, oh, so it shouldn't have.
If it's gone, shouldn't it be all on them?
If it's gone,
I just changed it so that I could move my trigger and echo.
I believe the way he writ that they go all on when you get closer. I think he might have changed.
So I moved that.
Oh no, that was.
Four LEDs
It's doing
instead.
it. Okay, so it's doing it. What it's not doing is they're not all on when. So then you want to add a statement. So if you go down where your series of if statements are, you'd say if, else if, or just else actually probably. Else parentheses, and then you could say, you know, CM greater than whatever 50 or 60 or even 100 to turn them all on. Or even if it's even for, oh yeah, because you're doing less than 10. So yeah, you might want to do greater than or equal to 40
Here it is with,
because then it would cover
four
all.
LEDs.
Yeah. Yeah, just so you're good with that, and then. This is done uploading, so go press that Control-Shift-M, that'll open the serial monitor. You can also so there is 86. However,
Press line.